Hi everyone, and welcome to OpenMined AMA. Ask me anything. OpenMined is an open source community focused on making the world more privacy preserving. In this AMA interview, you'll have the opportunity to ask questions of privacy experts from the OpenMined community. My name is Amel Sellami, and I'll be your host for the day. But first, let's introduce our guest for today, Varun. Mark, welcome.
Hey guys.
Hey, so Varun Khare is an AI enthusiast trying to decipher the principles behind cognition while ensuring the privacy and safety of the people. He graduated in computer science from IIT Kanpur and since then has worked in multiple research labs in neuroscience, program synthesis, and computer vision. At OpenMined, he is primarily responsible for leading the development of KotlinSyft, which is the Android worker for secure on-device learning. Mark Jimenez has worked as an iOS applications developer for the past 6 years, successfully launching projects like social network and messaging apps, having seen the tech landscape shift away from mobile. He's been grinding day out, learning data engineering and machine learning. For the next chapter in his life, he wants to dedicate his skills to something that can make a difference. Welcome, both of you.
Thank you, Mel.
Thank you, Emma.
Thank you. Great. So this is the second AMA part of the series, which is Federated Learning Month. First, we started the previous week with Patrick, and now it's with Farun and Mark. Thank you for joining us. So let's start first things with the small introduction about CotlinSyft and SwiftSyft and all these kind of things. What do you think? Okay.
Sure.
Okay. Great.
So I'll just describe a few things about Kotlin, then Mark
Okay.
can give the overall, right? So there are several aspects of on-device training, like Patrick already mentioned about PyGrid being there and PySwift being there, but there's this important component of Android or the mobile workers, right? As well as the web workers. So these worker libraries make it provide a uniform framework for any kind of training or inference on devices. So and since it supports PySwift, we have support for both PyTorch and TensorFlow, right? So yeah, Mark after this will describe everything, how it goes
Yeah.
on to implement. In
I
this
think
process.
we can start sharing Varun's screen.
Yes.
Um, so before we proceed with having a demo of the mobile workers, we just wanted to run through some of the concepts that Patrick mentioned from his last AMA. So one of those concepts is a model-centric federated learning. I'm sure he's already mentioned this. If you haven't watched his AMA, please do. So model-centric federated learning is where the model is stored in a server. In our case, that will be stored in PyGrid. And the data that we want to train it on is located on several remote workers. In this instance, they will be, we're going to show them the data being located on mobile workers. So how we're going to train that model is that mobile workers are going to register for a cycle in PyGrid. Now, what happens in a cycle is that for one whole it's going to be one whole round where workers will receive the model, train on their local data, and update the parameters of that model. Now, after a worker is done training their data, they send the diffs. The diffs are the difference from the updated model parameters you end up with after training your model on the device and the original model parameters that were given to you by PyGrid. Now, when you've generated that diff, you pass that back to PyGrid, where it's going to use the diffs from all the other workers to come up with an average aggregated model parameters, and end up with a better model than what it started with. Now, one of the objects that we're going to use heavily in model-centric federated learning, especially in PySwift or PyGrid, are plans. Now, plans are just a way to store a sequence of operations that operate on tensors. So it receives a set of tensors, and then it just produces an output tensor. Now, the way we're going to use plans for this demo is that we're going to create two plans. The first plan is the training plan. Training plan is going to accept the training tensors, the label tensors, all the other parameters, hyperparameters that you need to train and update the model. Also, we're going to create an averaging plan. Now, the averaging plan is the one that's going to be used by PyGrid to average all of the diffs that it's going to receive from all of the mobile workers. Now, show you how you create those training plan, averaging plan, and host them in PyGrid. Varun will show you the create plan notebook on uh, model-centric notebook.
Hi. Yeah, so I'll show how to implement all these plans and averaging plans in the notebook. I'm using PySwift's standard set of notebooks that are available in tutorial/model-centric. So you'll find the create plan notebook over there, right? So as Mark mentioned, we do plans essentially don't have a state, so we need to set the model params in the Torch script every time we run the plan, right? So this function is specifically defined for that. And so how do you define the actual neural net of it that's gonna inference? So it's just how you do it on PyTorch. So for our case, we had a simpler linear layer, two linear layers passed on via ReLU activation. So this is how you would define it in.
Varun,
Yeah.
sorry, but could you please make the text bigger? Like
Okay.
zoom in. Yeah, because people.
Yeah.
Great.
Is this
Thank you.
clear?
Yes, it's clear. Thank you.
Okay, so yeah, you can see here, like this neural net is exactly how you would define it in PyTorch, right? You have nn.functional, nn.linear, and everything that you need to do, hook out the PyTorch. Now, for defining the training plan, first you need to define the loss function after the neural network. And the loss function for our case is just a cross entropy softmax. So we take the logits, we normalize them, and we evaluate the log probabilities, right? So targets time log probabilities, this becomes your softmax cross entropy. So, and next is the optimization function. So for our demo purposes, we are just using naive stochastic gradient descent. So we just subtract the older updated gradients with the older parameters scaled by a linear rate. Right? The main magic comes in SwiftSyft.func2plan. So if you are familiar with TorchScript JIT.trace, that's similar to what func2plan does. So you have a Python function which evaluates certain values that you want and takes in input as training data, batch size, learning rate, and all the model parameters. The PySwift records all the operations that happens in between this Python function and creates a set of operations, as Mark mentioned, right? So you define your Python function, you have func2plan, then you need to build the plan, right? So you feed some random dummy data and then you build your plan. So at this step, the plan sets out all the set operations and feeds them into in the plan's code, right? So once we built it, we have a training plan.code, right? You can see you have transpose, mat, mul, add, relu, a whole set of long range of parameters. So once all this is done, you get your plan and your torch script. So since we support both web browsers and mobile workers, PySwift's internal representation of plan gets converted into TensorFlow for web workers and TorchScript for mobile workers. So what you see above is the internal representation. That's PyTorch representation, since we are using PyTorch in the backend at the moment. This thing should change eventually though, so I'm not the one to comment over there. So once you have Torch script, you get everything. Right. So the base framework basically tells what kind of code is present in the training plan. So if you set it as TensorFlow.js, you have TensorFlow plans, right? You can see tf.diff. Okay. Averaging plan, for our case, it's just simple: sum them up and divide them by total. So we build it just like the previous one, feeding dummy coefficients and everything. Then this is what you need to do. So once everything you have finished, you will create the grid client. So this is the static FL client, but I think in the newer notebooks, this is referenced as model-centric FL client. So I don't think there would be an issue with this running the newer ones as well. You initiate the grid one, you feed in the model's name and the version, and you feed in the client configuration and the server configurations. All the hyperparameters that you want inside the training while running on mobile workers, you can pass them via client config. Server config, obviously you have number of cycles that you want for the model to be trained, maximum and minimum upload and download speed to set the constraints on bandwidth, and the minimum and maximum number of workers. So this might seem a little cryptic, but it's also going to change eventually. No, I hope so. Then this JSON Web Token. So we support JWT authentication, right? So to have that kind of authentication, you need to set the public key at PyGrid so that it can verify all the private key accesses that the workers are giving. So you initiate a private key and a public key. You set the public key for server config, and then you host the model on PyGrid. So you must note that I have set the public key on PyGrid, right? So the private key needs to be supplied from the worker using a JSON Web Token. So it totally depends on the worker how he wants to get this token, and he can have a completely independent third-party authentication system to get the private key. For our case, we just encoded the private key into a token, and we stored it into the demo app directly as a file. Right? So that's it. That's how you host the plan on PyGrid. Now let's see how to run it. Right, here comes KotlinSyft. So PySwift models, as described, they can be written PyTorch or TensorFlow and can be trained and or used for inference on mobile devices, both Android and iOS. All the data is on the user device. You are not sending anything. It's completely safe and secure. KotlinSyft also supports full multi-threading and background execution. So if you want a background executor, or if you want to have multiple threaded execution for the Torch script plans, it will run by default on KotlinSyft. JWT authentication, as I mentioned, it's present. Then in the last AMA, Patrick also mentioned about best practices, right? So the app developers by default don't end up misusing the compute and networking resources of the device. It's one of the biggest problems for libraries to handle, and we do have a support for all of them. So charge detection, sleep and wake detection, Wi-Fi and meter network detection, they are present and enabled by default. Of course, you can override them, but we recommend not to. And so for Android, these detections are pretty easy to implement for background executor. You just need a work manager API and add them up. But it's pretty tedious if you want it in a foreground executor. And KotlinSyft allows you to just pull out a function and implement it directly. You don't have to go through all the tedious process of registering broadcast receivers for that. And for those of you who aren't familiar with RX Java, I hope you have some other mechanisms rather than handling callbacks, because obviously there's a huge amount of debate over handling uh, callbacks recursively, right? So we do support both reactive and callback patterns for implementing this. Secure multi-party computation and secure aggregation protocols. These are all in the future things. So they would be coming soon when we have protocols available in PySwift, but just hold tight for them. It will come. And so, yeah, if you want to go into details of what is MPC or secure aggregation, just KotlinSyft README has a few links for them. I hope Madeline put it. Yeah, it's already there. Right? So you can go through them over there and check out how it works. I'll start with, yeah.
I just said cool. Just one thing, please make sure to ask questions so that we can answer them later if you have. For now, for Varun and Mark, thank you. Yes, thank you
Okay.
very much.
So before diving into the code, let's have a quick overview of the library API, and then I'll show you how to write it in Android. Right. So we have a user ID. It's like, since we support third-party authentication, you would have some sort of user identity, right, to define who is your user. So you have that, and you do some sort of communication with your own server to get an authentication token that would be sent to the PyGrid. So you get your authentication token somehow, then you build the Swift configuration. So I mentioned, right, we have a set of inbuilt practices that are overridable. Then you can run multiple jobs inside the Swift worker. So all these kinds of parameters are configurable in via setting those in Swift configuration. So even though the library supports multiple job execution, we don't recommend you to have them for the similar reasons. And it is set to 1 by default, but you can override it. So once you have
Can you
the
please?
yeah,
Sorry,
it's,
Varun. But can you please increase the text size a bit?
sorry.
Yeah, that's better. Thanks.
So right, so you initiate the Swift worker from the Swift.get instance by feeding in the configuration and the authentication token. So the get instance is actually returns a singleton object. You can't have multiple Swift workers running in the same app lifecycle, which is it becomes a lot more tedious to handle jobs running across multiple workers in that case. Right. So, but if you do try to initiate multiple workers, you'll just get an error. Or if the worker has the same set of authentication token in the configuration parameters, you'll get the original worker initiated. So it's completely creation safe. And then there's you initiate a job on the Swift worker by feeding in the job's name and the version. So this is the same thing that you defined while hosting the model. Right? So the name and the version you defined while hosting it on the grid is the same one that you would be using here. Then for the quick start, I'm just going through the callback patterns since it's easier for everyone to understand. All kinds of error handlers and API handlers are done via job status subscriber. It's a class in KotlinSyft that allows you to override on ready, on rejected, and on error handlers. So on ready listener works when your model has downloaded all the parameters and the plans from the PyGrid. So, and you are just ready to begin your training process, right? So you you have hosted a set of plans on PyGrid, right? So which particular plan do you want to execute? So that would, you will just access that plan by its name or its key, and you repeat it for a certain number of steps. So this is again a hyperparameter. If you don't want to repeat it, you don't do it. It's completely dependent on you. We've initialized the batch value, the learning rate, and the batch data that are necessary, and they all are being initialized to an I value, which is the PyTorch wrapper for tensors. So if you are not familiar, you should check out PyTorch Android repository. Right. Then the batch data is data repository is something that for our case it's user implemented, but we eventually would be supporting a huge set of data loaders for you to just feed in the file name and get your data. But for now, it's implemented in the code directly. It returns a batch of data every time you ask for it. You get your model parameters just like this, and you feed them all into plan.execute function. This is what runs the torch script hidden behind. It takes up all your parameters and returns an output. The output is exactly the same you defined in the model over here. Yeah, so you'll get a loss and accuracy and updated parameters as an output. The same thing would be over here, right? So you have your updated parameters and your accuracy and the loss values. So once you get your updated parameters, you set those parameters again. So for the next iteration by update model, and do this for a certain number of steps. Once it's done, you create the diff that subtracts out the final parameters from the initial parameters from the final parameters and sends them out to the PyGrid via report function. Right. So as Mark told earlier, like there may be cases where your worker asks for the acceptance into a cycle and PyGrid rejects it, right? So all those kind of rejections would be handled over here. So either you run out of cycles that could be executed, or your worker just doesn't have sufficient bandwidth. So it will get rejected, and you'll call whatever handler is written inside it. On error handler, on the other case, handles any kinds of error that KotlinSyft throws internally. So there's a host of different kinds of errors, and I'll just quickly show them at the end, so you know how to map a particular error to a particular track catch below. Finally, you start your job by feeding in all the overridden handlers. Let's see how to run it. So on the left is my Android Studio, and on the right you can see my device that's currently that has already launched the particular app. For implementation, let's first begin with MNest activity. So that's the one that runs after I've given the URL to this. So this is the, since I hosted the PyGrid on a local instance, I entered the URL for my local area network. Right? You can see there are two buttons, start foreground and start background. They are both linked to two particular options, launch foreground cycle and launch background cycle. Each of them initiates a configuration parameter, initiates a data loader, and then calls the respective function in view model. Similarly over here. I'll go through these codes eventually, so don't worry about these. Other than that, all these are just the UI handlers that we have, the usual ones. Let's see what actually goes on in foreground training. So it initiates a training task, as you can see over here, and passes it on as a composite disposable. So for those of you who are not familiar with RxJava, Composite disposable allows us to add different kinds of training tasks that are running on multi-thread executions. So you can all clear those tasks, stop them, or resume them. Uh, then you can see there is a function like dispose training. Its main purpose is to clear up all the composite disposables and training tasks. Right? Work info observer attaches the background UI to the background task executor. So you saw, right? We were using training task everywhere. So it's a class that we defined in the demo app to make things easier for foreground and the background executor, right? So this is exactly on ready, on complete, on rejected, on error handlers as I defined earlier. On ready runs a training process which has the same code defined in the quick start guide. So this is done. Then this is the federated worker that runs the background executor. So I'm using the work manager API for all my background executions. And this is the coroutine worker. So for those of you who aren't very familiar with coroutines or suspended functions, it just is a scalable way of implementing multi-threaded environment. Right. So here also I have just given an authentication token, a base URL. I have initiated the configuration, the data loaders, and then pass them all into the await task function, which itself just runs the task that I defined earlier, right? This is the notification panel. Right. So this is the overall code structure for the demo app. I'll just show you how it runs because nothing works if you can't see it. Okay. I'm running the start foreground. It's checking for the download and the upload speeds. So we have enabled the minimum bandwidth constraints for the workers. So KotlinSyft first checks for the available bandwidth and accepts into the cycle only if we have a sufficient constraint. Since I'm on localhost, I don't have issues with connectivity. So you can see it's running training perfectly fine. Getting some loss values. Yeah, it's finished. And then you see training is done and the model is reported to Pygrid, right? Similarly, for the background executor, we see a persistent notification. That's compulsory for all the Android implementations. Wait, it will work. So once you have all your downloads and upload speed checked, it will begin the training process. Right, see, it's working. And you can see it started just where it left on the previous cycle. So once the previous cycle ended, the model was sent to Pygrid and the Pygrid ran an averaging plan over it. Right, once that's done, the model gets updated, and for the next cycles, all the workers initiate the parameters at the that was supplied by the previous workers, and you eventually see everything working. And now I'll show you how the battery constraints and the network constraints work. So as you can see, at the moment my device is on charging state, and I'm running the foreground executor. Right. If in between training cycle, say my device is removed from charging, or say my network breaks from a meter to unmetered to a metered network, I'll just stop training, and it will throw an error to the in the on error handler. That is job error throwable battery constraints failed. Right. So For implementing this, the as I showed, I had to do absolutely nothing for all this. So it's enabled by default, even for the foreground executor. And I guess that's about it for the KotlinSyft. I think we would be having questions after this, Samuel.
Uh, if people have any questions regarding this part, we can have like questions now and to answer them. But if not, we can move on to Mark, because I think most of the questions were related to the repo, to the talk, and all these kind of things.
Ah, awesome.
Okay, cool. Great demonstration, by the way.
Thank you.
Okay. Thank you, Varun.
Cool. Okay, we'll move to Mark, but please make sure to have to ask your questions in the live chat so that we can ask them later for Varun, for both Varun and Mark. Thank you. Go ahead, Mark.
Okay, I think we can start sharing my screen now. Uh, just tell me when it's all right. Okay,
Yes.
okay. Now, I'll just make sure that the font is something that's readable for you guys. Now, for on iOS for SwiftSyft, we do have similar features as that of KotlinSyft. I'm not going to run through all of this because most of it is just the same. But we do support training and inference, authentication using JSON Web Tokens. We support charge detection and Wi-Fi or network detection, just to make sure you don't use up your iPhone's resources. You can run on the foreground and the background. Um, Moving on, I think I'll just update this with the updated installation. Now, for installation, the package for SwiftSyft is found in CocoaPods. Now, I know at least one iOS developer is out there listening, Madeline. So, the SwiftSyft is on CocoaPods currently. This is the most popular dependency manager for Cocoa projects, not just on iOS, but also desktop clients. There also exists other package managers, but for SwiftSyft, we do have a hard dependency on LiveTorch iOS. This is the statically compiled library released by PyTorch. It's only available in CocoaPods. That's why we have to use CocoaPods for this library. Just so if you want to install it, you just add pod OpenMined SwiftSyft. This is similar to a Ruby gem file. The syntax is a similar one. Now, I'll just run through the code. The code is for SwiftSyft is simple. You just need two objects: the Swift client and the Swift job. The Swift client is where you specify the URL and optionally the authentication token for PyGrid. Now, the Swift client is what you'll use to create a Swift job. You create a Swift job by specifying the model name and the version. Now, if you were listening to the Create Plan Notebook lecture by Varun earlier, this is the same name of the training plan you hosted on PyGrid. Now, you create a new job with those specifications. For the Swift job, you attach a few handlers. The onReady handler is executed when you're accepted into the training cycle. The on-error handler is executed whenever you encounter any error during the training cycle. And then the on-rejected handler is executed when you're rejected from the cycle. For example, when your upload and download speed isn't good enough for the specifications mentioned in the server configuration when your training plan was uploaded. Or maybe there's a lot more workers already on the cycle and you're not really needed. Now, going back to the onReady handler, this is where the meat of the training is done. So this is a reminder, this is executed when you're accepted into the cycle. You are given a plan, the client configuration. The client configuration is the hyperparameters you're going to use for your training. This can include batch size or the learning rate. And the model report is a function you're going to use to report the diffs back to PyGrid. Now here I'm just loading the MNIST data in batches. This is analogous to the data loader that we have in PyTorch. So this just loads it in batches as specified by the client configuration. Then I just loop through the batch and the label. On iOS, when we're looping through a lot of data that is stored on the memory, we need to specify an auto release pool. So this just means that I want to release all of the memory and RAM at the end of this particular loop. We need to specify this because Swift is reference counted. It isn't garbage collected. So we need to clear things up manually at the end of every loop. Then we're just processing the MNIST data in the Swift arrays. Uh, and then we're passing it on to a training data and validation data struct. When we pass that training data, validation data, client configuration for hyperparameters into the plan.execute method, it will optionally return the loss from the uh, the training plan that we did. After looping through all of this, uh, you can now generate the diff data. The plan remembers the original parameters and its updated parameters after running through all the data. So just comment generate diff data, you'll end up with a diff state data, and then you will just call the model report function to pass this diff data back into PyGrid. Uh, so that's basically the onReady handler. You start the registration for authentication and then your registration for the cycle with the Swift job.start method. Here you already specify the charge detection. If you want the training cycle to occur only when your phone is plugged in, or Wi-Fi detection if it has Wi-Fi connection, so you don't use up all of your cellular data. Now, before I proceed into the demo, I just want to go through quickly how background execution is done using SwiftSyft. Now, if you don't know already, background execution for apps has been very restricted on iOS up until iOS 13. Basically, there are only certain situations before that you were allowed to execute data while your app is in the background. So before you could only do that with VoIP call, you can't do that anymore. Also, maybe if your app is playing music, uh, I think those are also when you're handling those who were it before. Now, if you needed to do any scheduled jobs, you couldn't do that. In iOS 13, they released a background task scheduler. Now, the background task scheduler, I think the best comparison for this is just like maybe a cron job that we schedule for the background. I think that's the best comparison for it. This was made specifically so that you could use maybe a machine learning training job on your device, or you need to update something on your device. For our use case, we use it for machine learning. Now, the background task scheduler is heavily associated with the client code, but you need to register a background task identifier on the app itself, and then you just register on the you register a closure that's going to be executed when the background task is called. Now here, this just executes all of the code that I mentioned earlier: the Swift client, the Swift job. Now, to submit a background processing task request, you generate one here. You specify a BG processing task request. This is a task request we want for a machine learning training job. Now here we specify a requires external power that you want the background task to execute while the phone is plugged in. Requires network connectivity. We want it to execute with a Wi-Fi connection. and then we just submit that processing task request. The reason why we specify both of these to be true in a background task is that on iOS, uh, if you reach for background tasks specifically, if you reach go past a certain CPU usage limit or a RAM limit, uh, your process is going to be shut down. So if you don't specify that your background task needs external power, uh, it's going to be shut down. Unfortunately, for machine learning tasks, uh, we need a lot of CPU usage. You need to specify requires external power, unless you're just using it for one-off images that you want to train on. Now next, I'll show you the demo of SwiftSyft running on MS Data. Can you see? Can you guys see the simulator?
Yes,
Uh,
yes.
Now I'm just gonna authenticate with a Pygrid server running locally. Then I'm gonna give it my upload and download speed. I'm just gonna wait for a few seconds. Uh, I'll just check what. Okay, now I'm accepted to this training cycle, and then I'm loading the MS data. We're not uploading the MS data server. We're just loading the data to train with the training plan. My computer's running a little slowly. Uh,
It's okay.
okay, here we go. Now we're running through the batches of MNIST images. Uh, Here I'm running through the entire MNIST train data. I just wanted to check if I could run through the entire batch without getting into problems. But if you run this long enough, you're going to be able to see the loss. Because here I'm just plotting the loss from executing the training plan. You're going to see this go down right below around here. But it's going to take a few minutes because I'm loading the entire training data. We don't need to wait for this. My presentation's done here, but I do want to say that if you guys are interested in contributing to SwiftSyft, uh, we have a bunch of issues that can be found on the repo. I think KotlinSyft has a lot of as well marked as good first issues. Aside from the issues or documentation, one thing that I do want people to do is if you can try to create your own projects on using SwiftSyft, KotlinSyft. There's a lot of machine learning projects that are specifically used on mobile that is hard to, especially for Federator, that is hard to replicate on notebooks or maybe even the web. So I do want a lot of feedback on how much more we can improve the API, make to make it easier for you guys to use this. Here you're already seeing it going down, but this is going to go down further uh, until we go run through all of MS data. The diffs are generated and then passed back to Pygrid. I think that's it for me, Amel.
Cool. Great. Thank you very much, Mark and Varun. That was very instructive. If you don't mind, let's start with the questions. If that's okay with you, okay?
Sure, sure.
Sure.
Cool. So the first question is, I'm running through them. Okay. So what cool features do you plan to add in the future?
Okay, I'll start with features in Kotlin. So that's pretty huge. Like we have a huge set of milestones set before us, and like I don't know which should be the
I think
goals.
start, stop, resume
Yeah.
is something that
So
a lot of people request because we need to a way to for example, when the power is interrupted or the Wi-Fi connection stops, we need a way to resume the training, especially for long-running training jobs where we're running through a lot. For example, the long list of MS images we have on SwiftSyft, that's something that's going to have a stop and resume in order to work.
Yeah, yeah, and as we mentioned in between, there's a open issue for data loader API. So currently the library uses the data loader has to be written by the user, right? It's in the Android, but we got feedback from a few of our contributors who told like it's not uh, like beginner friendly, and we should have some data loaders just like PyTorch has. So that's one of the features that's on our hot list. And then, as Mark mentioned, we have a stop and resume cycle for the futures so that you are able to, once the job is stopped in between, you can resume it later on and you can have
Also, yeah,
checkpoints in
yeah,
between.
I forgot for long-term features, we do want to integrate secure multi-party computation and then the differential privacy. I think OpenMind already has uh, differential privacy libraries for the mobile uh, for mobile. We do want to integrate them into probably another project or maybe the MS project.
Yeah, cool. There's lots to be done. Okay,
Yeah.
so
And
yeah, sorry, go ahead.
yeah, I was just saying, we need lots of contributors for implementing those issues.
Cool.
Yeah.
Yeah.
Yeah, cool. So another question is, how could people start contributing to KotlinSyft and SwiftSyft? Any advice?
Okay, so for KotlinSyft, it's there are, as Mark mentioned, there are good first issues that are marked. For they are mostly the documentation and the testing tickets. So documentation tickets lets you get familiarized with the code base that's available in the library. But then there are other issues that we have recently started, and that's about writing tutorials. So one of our contributor began this journey, and he wrote our first tutorial for KotlinSyft, and that essentially tries to handle different kinds of data sets while loading the files. So we hope to have lots more a huge set of tutorials that you could just go on and copy paste your code. So I would
Yeah.
recommend any beginner to work on those issues. Yeah.
No, we do.
Mark?
We have good first. If you filter the issues by label, we you can look for like good first issue label issues that most of them are documentation or unit tests. Also, you don't. One thing that you may miss if you want to look for give feature suggestions, I do suggest that uh, if you already know how to make Swift iOS apps or KotlinSyft apps, but just try making a full blown project. Uh, there's probably a few things that we're missing that we can make it things easier for you. Uh, but a lot of that can be found in context when you're making your own project. Uh, we will if you do end up finishing your own project on using SwiftSyft or KotlinSyft, you can share it on Slack, and we will be proud to work with you on whatever way to make it more convenient.
Cool. Great. Thank you very much. Okay. I think there is a technical question, if you don't mind. So yeah. So someone asked, do you mind if I ask a question about the create plan? So the question is, I'm keep getting an error saying key error data when trying to host the federated training plan.
Uh,
This is from createplan.ipnb, and I've
yeah,
seen
yeah,
been spending days to
I
resolve
totally
it.
understand. It's something that uh, I encountered this earlier, but yeah, I don't know if you should file this for PySet or with PyGrid.
Uh,
Uh,
Yeah, so this issue is more related to the PySwift and Pygrid continuously changing, and the libraries need to support them. So I think 0.2.7 PySwift version had complete support for all the libraries, and
Cool.
this data error is just the renaming that happened on Pygrid later on.
Okay.
He can just shoot us the message on Slack, and we'll help
Okay.
him out with the correct points.
Yeah,
Okay.
because we
Great.
need to coordinate with the Pygrid team on what stable version we can ping.
Cool. Great. Thank you very much. Okay. So another question is, um, okay. Well, if it's not out of the scope of this presentation, can you tell us how we perform for inference on the edge devices with updated models?
No, right
Uh,
now, yeah, right now,
Go ahead.
uh, that's gonna be part of the cycle-less, uh, cycle-less uh, feature that
Mhm.
we want the mobile workers to be able to download the models without going through the cycle. I think there's already APIs being done on PyGrid for that. We haven't added the APIs yet on the mobile workers, but it's something that we do plan. That's one of the first requests actually when we release the libraries.
Uh,
Cool.
and also there's a quite hacky like step to do this if you don't wanna wait for the Pygate. So like if you don't like you are ready to authenticate with the Pygate, even if you are not training a model on it, you can just initiate a new plan inside the create plan notebook. So create plan hosts multiple plans, right? So there can be another plan which does not do the backward call inside it while implementing the function. And you build that plan and you send it via Pygrid. At the worker, you just run it just like any other plan, and you feed in plan.execute function. So you would be able to run the inference, but yeah, it would always require authentication with the Pygrid first. That would eventually be removed.
Cool. Thank you. Okay. So another question is support for protocols added? If not, when can we expect it?
That's gonna be dependent on PySwift. I don't. Yeah, it's definitely something that's planned. We can't speak to it yet. When's scheduled for implementing it on the mobile workers.
Cool.
Yeah, so like I think they are waiting for PySwift 0.3.0 for that has a major refactor across all the core library core implementations. So I guess protocols would be coming after that. Pretty far. I'm sorry.
Yeah. Cool. Another question is, I had a quick review over the iOS code and I see all deep learning stuff is done with the PyTorch library in C++. Is there any plan to use the native libraries which have GPU acceleration?
The runtime is we have to use the. I think the we do. How do I start this? We do use. I think the limitation is that we use Torch script as the internal representation of the model and the plan as it's passed around between PySwift and the mobile workers. Because we have to use Torch script, we need to use LiveTorch, C++. We can't really. We have to rely on them uh, for optimizing the Torch script engine on on iOS. That's something that's planned uh, in the future. The last time we talked to them, it's definitely something that they should do. But we have no timeline yet, and because we do rely on them for the runtime engine on that, it's something that is out of our hands. I think the best we can do is like do concurrency for data loading, data loaders, similar to how it's done on PySwift. I mean on PyTorch. But the runtime itself for executing the plans, we're tied to how LiveTorch, when LiveTorch is going to implement something that's takes advantage of SIMD or the new concurrency APIs for iOS.
Yeah, cool. Great. Thank you very much, guys. That was very awesome. I don't think that there are any other questions that I have missed. So I think we can stop here if you don't have any other things to add. It was really instructive and really great. Thank you for joining us today. And see you next time in the next AMA. Bye, everyone.
Bye,
Thank you, Amel.
guys. Thank you,
Thank
Amel.
you. Bye.
Thank you, Madeline.